Alright, today we're doing section 2.5. This is our last section that we will be doing in chapter 2. So we will have a test on chapter 2 on Friday. Okay, so section 2.5 is about using the distributive property to simplify expression. Alright, before we start using our distributive property, let's do a little review with these warm-ups. Not here. Not here. Kion, what'd you get for number 1? Positive or negative 1? Wonderful. A positive divided by a negative is a negative, so negative 1. Tariana, what'd you get on number 2? On number 2, our answer would also be negative. Again, we have a positive divided by a negative. Number 3 is a little tricky. Lexi, what'd you get? Close. I agree that it will be negative, but I think it'll stay a fraction because our smaller numbers on top. So negative 8 divided by 72, that means we're going to end up with a negative 1/9. Okay, if the bigger number is on the bottom, that means it stays a fraction. When the bigger number's on the top, that's when we usually end up with an integer or a whole number. Alright, and last on number 4, we have a negative divided by a negative. Carl, what did you get?
7.
Positive 7. Sounds good. Today is all about the distributive property. It's also what tomorrow and probably Wednesday will be about also. For all real numbers a, b, and c, if you take a times the quantity b plus c, that's the same as taking a times b plus a times c. You can also distribute from the end of the parentheses instead. You end up getting the same thing. So usually on these, this is when we kind of drew those little arc lines to show that we distribute. For example, we could take 3 times the quantity 4 plus 5. That would be the same as 3 times 4 plus 3 times 5. So we take the number or variable, whatever it is out in front, and multiply it to both things inside the parentheses. But we keep that addition sign in between them. When we do that, of course, 3 times 4 is 12. And 3 times 5 is 15. We could add those together to get 27. That's not the only way to do that problem. We've done this before by adding up first and then multiplying by 3. Okay. But not all of the problems that we see are going to just have numbers in them. For example, we could have negative 2 times x plus 10. On a problem like this, when we distribute, we take negative 2 times x plus negative 2 times 10. So again, what was out in front got multiplied to both things inside. And we can clean it up a little bit. We can write this as negative 2x plus negative times a positive is a negative 20. Or instead of writing it as adding a negative, you can just write it as subtraction. So any of these would be acceptable. The bottom one being the one we'll see most often. One use of the distributive property is to make mental math easier. So instead of having to take 5 times 83, we can take 5 times 80 plus 3. 80 plus 3 is the same as 83, so these are equal to each other. So when I distribute here, I'm taking 5 times 80 plus 5 times 3. These are both products that you should be able to work out easier separated than it is to work it out together. Okay, 5 times 80. Anybody want to raise their hand? Yes, sir. 400. We take 5 times 8 and then add the other 0 on the end. I'm hoping we all know 5 times 3 is 15. Those two numbers are pretty easy to add together. Okay, so especially when we don't have calculators in this chapter, we can use the distributive property to make our mental math easier. Number 2. So they did not split this one up for us, so we have to be able to split it up. So I'm going to split it up into 9 plus 0.5. Remember, 0.5 is a half, 1/2. So we take 6 times 9 plus 6 times 1/2. What's 6 times 9? 54. Plus, what's half of 6? 3. We add them together, we get 57. So we use the distributive property to make this math a little bit easier to do. Alright, on our next examples, we need to split these up. So we should have split this number 3 up into being 6 times 40 plus 8. Then we should have distributed the 6. So we would have 6 times 40 plus 6 times 8. Make sure you're not forgetting to bring down that sign, that addition sign. Deja, what did you get for 6 times 40? What would you get if you did 6 times 40? Okay, so 6 times 40 gives us 240 plus, Connie, what's 6 times 8? Six times 8 gave us 48. We add them together, we should get 288. Alright, on number 4. On this one, we've got 4 times 3 and 1/4. So 4 times 3 plus 0.25 is 1/4. We distribute 4 times 3 plus 4 times 1/4. 4 times 3 is 12. 4 times 1/4 is 1. We end up with 13. The distributive property is most often used when multiplying an integer by a binomial that contains a variable or variables. So that's what we see here. We have an integer being multiplied to a binomial. That means there are 2 terms in here. Later on, we might see it where there's more than 2 terms inside of the parentheses. So once again, this first step I will not always expect to be seen written out like this, but this is what the distributive property tells us. Okay, so this first step I will not always expect to be seen, especially once we've gotten stronger in this skill. You won't want to take the time to do that, that's fine. But the distributive property tells us that we can take 5 times x plus 5 times 2. And then we would just simplify it. 5 times x is 5x. 5 times 2 is 10. And then we are finished. Normally, I will expect to see you go straight down to the answer. If you need to write out what the distributive property means for now, that's fine. We talked on that first slide about the distributive property that we don't only distribute from the front of the parentheses, we can also distribute from the back of the parentheses. That means that we are able to take this 4 times 6y and 4 times 7. So written out, that's what it would look like. 4 times 6y plus 4 times 7. Can anybody raise their hand and tell me what 4 times 6y is? Keon? 24y. 24y, very good. Plus, Jeriel? 4 times 7 is 28. It's a good question. We cannot combine those because of the y. They are not like terms, so we leave it alone there. All right, on we go. On this one, we've got 3 times k plus 3 times 8. Tariana? What, do you have a question?
Oh, yeah, I would say, do we bring the 3K down? Do we bring it down?
To the next part?
Yeah.
Mm-hmm.
Okay.
Do you want to answer it?
Yeah.
What is it?
I got 3K plus 24.
Wonderful. 3k plus 24 sounds good. Again, we don't need the parentheses separating the 3 and the k. These both mean multiplication. If you really like the parentheses, you can keep them, but you don't need them. All right, on number 8, we are distributing from the back. So we have 2 times 3p plus 2 times 4. Keon, what did you get?
6p plus 8.
Wonderful. 6p plus 8. Can we combine those?
No.
No. They are not like terms. We cannot combine them. So these are the 2 answers we get for those problems. So you'll want to fill this in on your notes. Multiplication is distributive with respect to subtraction as well as addition. What this means is that we can still distribute over subtraction. So we can take 4 times a. The difference here is that we're going to keep this subtraction sign. On the last ones we had addition signs. Now it's a subtraction sign. But we're still taking 4 times both the a and the 6. All right, 4 times a is just 4a minus 4 times 6 is 24. We cannot combine them. They are not like terms, so we are finished. On number 10, again, we can distribute from the back instead of from the front. 5 times y minus, keep that subtraction sign, 5 times 10 would give us 5y minus 50. Again, not like terms, cannot be combined. On number 11, we know we need to combine the 9k with the 2k, but what operation do we need to do? Subtract them. So 9k minus 2k would give us 7k minus 7. Alright, number 14. Shannon, what did you get?
Negative 4M.
Just negative 4m? Okay. I think we need to use this negative 4m and combine it with the positive 2m. So if I take negative 4 plus 2, what do I get? Close. Negative 2m. Remember, if the signs are different, we subtract the values and keep the sign of the number with the bigger value. What happens with this minus 12? It just comes down. There's nothing to combine with it, so it's just part of our answer. Questions about 14? All right, on 15 and 16, you should have at least had 2 lines of work shown. Well, 1 line of work and then an answer. We cannot go straight to our answer. So the first thing we would do would be to distribute the 7, which means the 5n is just hanging out in front. We distribute the 7, so that gives us plus 7n minus 7 times 3 is 21. Alright, so then after that, we have to combine our like terms. Jamal, what did you get?
12 minus 21.
Wonderful. We add the ends together. We're still subtracting 21 on the end. On number 16, again, we've got 2 steps to get to our answer. The first step is distributing. So 3 times 1 is 3, plus 3 times z is 3z. The 7 at the end, we're just adding on to the end. So we only distribute when something is right in front of a set of parentheses without an addition or subtraction sign in between it. So the 3 gets distributed, the 7 does not. Then we go to combine like terms. Houston, what did you get?
6 plus 7.
We're close. So the 3z has nothing to combine with it, so it just stays 3z. And then we add the 3 and the 7 to get 10. Okay. So we have to leave the 3z alone since there's nothing to combine with it. If you put 10 plus 3z, that's also correct. Either way is fine. I prefer it the first way, but addition is commutative, so both are correct. Alright, on 17 we are distributing a smiley face to triangle plus arrow. So what that would look like is smiley face times triangle plus smiley face times arrow. We could take this a step further and say, well, then this would make it a smiley triangle plus a smiley arrow. Alright, we're combining them, multiplying them together. It's a little bit weirder to do that part on 18, but we can still show the first step. So we've got a star times a moon, or a crescent, minus a star times a heart. Combining those is a little bit harder than combining a smiley face with a shape, but you might be able to make it work. So that's just showing that you can still represent the distributive property with symbols. You don't need it to always be numbers and letters. Okay, then our homework assignment is on pages 67 and 68. You're doing the written exercises, 2 through 8 evens, 26 through 48 evens.